A warm welcome to all the viewers. In this session, we will be discussing about what is statistics, especially from the point of view of research. In research, we often come across two important terms which are descriptive statistics and inferential statistics. What are they? How are they so useful? So we are going to discuss all of this. Just stay tuned and keep watching. Statistics is the science of collecting, organizing, analyzing, interpreting and presenting the data to find patterns, make predictions and draw conclusions. Parameter, which tells us the characteristics of the population, and statistics, which tells us the characteristics of the sample which is taken from that population. So that's the difference between parameter and statistics. For an instance, if I say population mean, that is a parameter which tells us about the average of the population. However, if I say sample mean, that indicates I'm talking about a statistic which is a measure of sample characteristic. To assess the data which we have gathered, we have two routes. One is descriptive statistics and the other is inferential statistics. As the name suggests, descriptive means wherein we are just describing the character of the data which we have gathered. It can be done through frequency distribution, which is actually the count of an event happening, count of a particular data point, how often that occurs in the series of the data, how important is it. That is revealed through the frequency distribution. Say, how many males were there in your study? That is frequency distribution. Second is measures of central tendency. The centrality of the data means what is the mean, median and mode of the data. When we talk about mean, we can take out the mean only if we have continuous data. We can talk about median in case the data is ordinal in nature. And we can talk about mode, which is the highest occurring value in case the data is on nominal level or categorical level. Then only mean, median, mode makes sense in their particular context. Third is measures of dispersion, wherein we talk about how spread is the data. What is the range? That is the difference between the maximum and the minimum. What is the variance? How spread out is the each data point or each observation from the mean score? Then we take out the average of that to determine the variance of that data series or data set. Square root of variance tells us the standard deviation. Why do we need a standard deviation? Why can't we just go with the variance? Because standard deviation is a standardized form of variance which is mentioned in terms of the units which are used for actual measurement of the data. So the actual measuring units of the data, if we want to see in those terms, we take out the standard deviation, which is the square root of the variance. Next is interquartile range. Interquartile range tells us it is the range where 50% of our data points are lying. I'll be talking more about it with the help of a box plot. Just stay tuned and keep watching. It is going to be a very interesting session for all. Then we come to inferential statistics. Inferential means you are going to infer the findings which you got in as a result through the sample data analysis on the entire population, right? That is the purpose of research. You are collecting a sample from the population, conducting some tests, and then the results are going to be inferred for the entire population. If they are significant, you can say with statistical confidence that yes, they apply to the entire population. If the results are insignificant, then you say that you fail to achieve the results which can be applied to the entire population. In that case, you can try to increase the sample size to get a significant result. Here in inferential statistics, we have a number of tests depending on your study objectives, depending upon the type of data which you have collected, depending upon the type of analysis or relationship between variables you want to take out. For an instance, correlation. What is the relationship between two variables? If one increases, does other also increase or it decreases? If one increases and the other also increases, we call it positive correlation. If one increases and other decreases, we call it negative correlation. Then is regression. How is regression different from correlation? Regression is used for predictive analysis, predicting the value of a third variable. Then is hypothesis testing, wherein you lay the hypothesis, an alternate and a null hypothesis. Say, the sample mean is not significantly different from the population mean. In case you are doing a one sample t-test or a z-test, this is your null hypothesis. The alternate would be the sample mean is significantly different from the population mean. In this case, in case you are doing a two sample test, then you can state the hypothesis likewise. So it's important to learn about hypothesis testing as well. Then comparison, as you do in case of mean comparison, when you are doing ANOVA, analysis of variances. Now, in ANOVA, though we say it's analysis of variance, but actually we are comparing the means through the variances of the data sets, through the variances of the groups involved in the analysis. So, these are few of the techniques which are used for inferential statistics. Both the descriptive and inferential statistics can be pictorially represented through histograms, distribution curves, box plots, bar graph, pie chart, scatter plots, tree map, etc. Now, let us concentrate upon the measures of central tendency for ungrouped data, wherein we don't have any groups. We have a series of data and we are going to analyze it. It's ungrouped data. Group data means when you have intervals, when you have groups defined. Say for an instance, marks of the students ranging from 0 to 25, 25 to 50, 50 to 75 and 75 to 100 if it's a 100 marks paper. So in that case, how many students do fall in the first category, which is 0 to 25? How many do fall in the second category, which is 25 to 50? That is known as group data. But here we are going to discuss about ungrouped data. As you see here, the marks are mentioned over here in a series form and the number of students falling on each number are mentioned here. There's no group over here, right? So mean is the average of the given data set. How to take it out? You just add up the different marks. After multiplying them with the frequency, say there's one student on 4, 5 marks is secured by 3 students, 6 marks are secured by 5 students. So in this case, what will I do? 4 into 1. plus 5 into 3 plus 6 into 5 plus 7 into 2 plus 8 into 3 plus 9 into 1 divided by number of students. This is small n. So divided by number of students, that is 1, 3, that makes 4, and 5, 9, 11, 14 and 15. So divided by 15, that is the n. Sample size, number of students. You get the mean. When we talk about median, it is the middle value in a data set when arranged in order, separating the upper half from the lower half. In case we have odd n, as in the case we have 15 students over here. So in that case, what would be the median? It would be the middle point. So how to get that? We can easily get it. N plus 1 divided by 2 is the formula. So 15 plus 1, 16 divided by 2, that gives us 8. So you just see closely. 1, 3, that makes 4, and 4 and 4. Here there are 5 students lying on 6, right? But we want to take the 8th position. 8th point is the median. What is that 8th point? It is 6, right? 6. So that is the 8th point, and that is the median. In case we had 16 students, that's an even number, then we use this formula. Value at n by 2 plus value at n by 2 plus 1 divided by 2. That's the formula. If we had 16 students or 14 students, that's an even number of students. What is mode? Mode is a value that appears most frequently in a data set, representing the most common or popular data point. Now, looking at this chart, this table, can you tell me what is the mode over here? It is that value which appears most frequently. So we see that 6 marks is occurring most frequently, as in 5 students are lying on 6. If we see 5, there are only 3 students lying on 5 marks. But on 6, this marks 6 is secured by 5 students, which is the maximum in this number of students. So that is the mode, a value that appears most frequently. So 6 is the mode. Then we have frequency. Frequency is simply the number of times a specific data point or event occurs in a data set. So if I want to see how many male students were there, say in this number of students, though I have not mentioned it over here, but if I want to see, so I have male and females. So how many male students are lying at a specific data point, that is marks 6 out of this total number of students of 5. So in that case I can say, if there are 3 male students, I can say 3 male students. 3 is the frequency of male students lying upon 6 marks. They have secured 6 marks, right? That is frequency. That's how you use it. Now this is a dot plot of the same table which I have drawn over here. You can see on 4 there is 1 student, on 5 there are 3, on 6 there are 5, 7 we have 2, 8 we have 3 students, and 9 we have 1, right? If I say what is the range in this case, so it's simple, the maximum value minus the minimum value. So maximum marks is 9, minimum is 4, 9 minus 4 is 5, 5 is the range. That is a measure of dispersion of the data. How spread is my data? That is range. It's the simplest way to assess the deviation, assess the dispersion in your data set. It's not that appropriate. It's just a basic term. So then we go in for seeing the variance, standard deviation, and interquartile range. Interquartile range makes a lot more sense than simply mentioning the range. What is that interquartile range? Let us check it out. So these are the measures of dispersion for ungrouped data. Range, which is the difference between the highest and the lowest value, as I told you. Maximum value minus minimum value, 9 minus 4 in our case, that is 5. Variance is the distance of any data point or observation in the data set from the mean of the data set. It is a single value because it's the average of the squared distances of all the data points from the mean, thus providing a single value which summarizes the entire data set spread. So you see here, xi is the data point, say 4 marks, minus the mean, cumulative mean of all the scores which were there, which I told you earlier how to calculate the mean, and we calculated the mean when we are doing measures of centrality, right? So put that mean over here and say the first score was 4. 4 minus the mean, then squaring it up, summing up all the deviations of all the data points from the mean, and then in the denominator you put n minus 1. N is the sample size, which is 15 in our case, minus 1, that is 14. Why n minus 1? I have thoroughly discussed it in my previous video. Still, once to recall, because we have one lesser degree of freedom in case of samples. Had it been for the population, then we don't do n minus 1, we take the population size. Then, to standardize the variance to the same measurements units on which the data was measured, we compute the standard deviation, which is nothing but the under root, the square root of variance. So it's the same formula. If I put a square root of that formula, take out the square root, that is the standard deviation. Now coming over to interquartile range for ungrouped data. It's a statistical measure showing the spread of the middle 50% of data, calculated as the difference between the third quartile, that is 75th percentile of the data, and the first quartile, which is the 25th percentile, and visually represented by the width of the box indicating data concentration. So smaller is the interquartile range, that's the difference between Q3 and Q1. Lesser is the spread of your data, it's more concentrated, and larger the interquartile range, that shows more dispersed data, right? So if you have two different data sets, you can compare them on the spread using interquartile range. One having smaller IQR shows less spread, and the one having larger IQR shows more spread out data. Herein, when you see the minimum and the maximum, so that's the threshold wherein the values of the data set can lie, beyond which you have the outliers. So that is something special and specific to interquartile range, and that makes it better assessment of the dispersion than just referring to the simple range, because it does not consider outliers when we are calculating interquartile range. But in range, even if there's one data point, say only one student in a class securing 1 mark out of a test of 10 marks, and the maximum was 9, then the range would be 9 minus 1, that is 8. But if we are talking about interquartile range, and there's just one student in the class who is securing 1 mark out of 10 marks paper, and all others are beyond 4 or 5 marks, then in that case we will say that there is a large amount of difference between 1 and 5, that's the difference of 4, and maybe this one person, one student is an outlier because his or her marks are quite unexpected, quite different, quite deviating from the rest of the marks of the students, right? So where do these outliers lie? They lie beyond 1.5 times of the interquartile range. So whatever interquartile range you calculated, just stay tuned. I'm going to tell you how to calculate this in a while. 1.5 times of the interquartile range. Beyond that, you have the outliers on the left and on the right, on the lower and the upper limit, right? So that's how you get outliers. That's why it is great for comparing variability between data sets or groups. Now, here is a calculation of variance on the same data set which we saw for measures of central tendency. The formula for variance, which we have already discussed. These are the marks of the students, and 6.4 was the mean, right? So deviation is data point minus mean. 4 minus 6.4. That's why x minus 6.4. X stands for 4 over here. Then the second row, x stands for 5. In the third row, x stands for 5 again. So that's why you see minus 1.4, minus 1.4. 5 minus 6.4 is minus 1.4. So you take out this deviation and then you square up that deviation. You see squaring minus 2.4 gives you 5.76. Squaring minus 1.4 gives you 1.96. And then you add up. Then you sum up all of them, because the formula says that you sum up all the deviations square. Square of all the deviations you have to be summed up. You come to 27.60. And you put that value 27.60 in the numerator, and in the denominator you put n, which is the sample size 15. 15 minus 1 is 14, and you arrive at a variance of 1.97. Simply, if you will take the square root of 1.97, you come over here, standard deviation, square root of 1.97 will give you 1.40, right? So this is in the standardized terms, in terms of the marks which were given to the students. So the standard deviation is 1.40. Then interquartile range, that is Q3 minus Q1, the distance between Q3 minus Q1. The median in this case, as we discussed earlier, is 6. I told you earlier how to get 6 when we were discussing measures of central tendency. So the median is 6. That is the Q2 value in case of interquartile range, right? So median is same as Q2 value. Then lower half excluding median. So below 6, how many values were there? There were 7, right? Because this is the 8th value. So we have 1, 2, 3, 4, 5, 6, 7. Next, upper half. Beyond 6, which is the 8th value, 9, 10, 11, 12, 13, 14, 15. So that makes up the data of 15, right? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So 14. In between is the median, 6. So that's how we have a data of 15 students. How do you get this Q1 5? It is the median of this series. You see here, 1, 2, 3, 4, 5, 6, 7, odd series, right? So in case of odd series, you see 5 is the median. It's lying in middle. 3 are towards the left of 5 and 3 values are towards the right. So we have 5 as the median. This median is the lower half median, which is Q1, the position of Q1, which is 5. And the upper half, you have 6, 7, 7, 8, 8, 8, 9. Again you have 7. So 3 lying left of the side of 8 and 3 lying right of the side of 8. You have median 8. So this is the upper half, 8. 8 minus 5, Q3 minus Q1 gives you 3. That is the interquartile range, right? So that is how you calculate the interquartile range. I hope this session was quite important and useful for all, and you will definitely share it with your friends and faculty colleagues. See you next time with some more informative content. Till then, keep supporting the channel and thanks for viewing.